Welcome to Statics classes by Civil Thinking, and today we are going to solve a problem on resultant of force systems. Now before I move on, I suggest to you to please watch the video lectures in sequence so that you understand better. Now the playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the problem, find the resultant of the force system shown in figure. Now this is a figure, and as we can see very clear, we have a concurrent force system because all the forces are intersecting at this point, right? So this is a concurrent force system, and the best method to use to find the resultant of concurrent force system is the method of projections, right? Method of projections. In this method of projections, what we do, we find the summation of forces in the x direction and calculate them. Also, we find the summation of forces in the y direction and calculate, right? Then we find the resultant, the magnitude of resultant. It is whole under root of summation of f of x square plus summation of f of y square, right? In this way, we find the method of projections, right? So let us follow these steps so that we solve this. Now let us assume this is x-axis and this is y-axis, right? Now what we have to do, we have to resolve all the forces in x and y direction. We will find the component of this force 150 pound in x and y direction. We will also find the component of this force along y and x direction. We will also find the component of this force 100 pound along y and x direction, and 200 pound is already in the x direction. Then we will find all the forces in x direction and calculate the value. Then we will find sum of all the values in y direction and calculate the value. Then we will apply whole under root of summation of f of x square plus sum of f of y square. That will give us the magnitude of the resultant, right? So if you don't know about resolving a force, we will find the force of each along x and y component. If you don't know about that, please watch my video lecture on resolving the forces. Okay, so let's begin. Now let's look at this force first. 150 pounds. The x component is in this direction. 150, the x component of 150 is in this direction, right? So it is 150 cos 60 degrees, and the y component of this is in this direction. It is 150 sine 60, right? So we have resolved this force, right? So let us move on to this force. Now the x component will be in this direction, 150 cos 60 degrees, right? And the y component of this force will be in this direction again. It will be 150 sine 60, right? So we have found the x and y component of this force also. Now let us find the x component of this force. It will be in this direction. It will be cos 30 degree, right? This will be the x component. Now the y component of this 100 pound will be in this direction. It will be 100 sine 30 degrees, right? Now this 200 pound is already in the x direction, so we don't have to find its components, right? So let us assume the forces towards right, they are positive, and forces towards left, they are negative. Now so let us find the summation of forces along x direction. Now 150 cos 60 degrees and 200 pound, they are both towards right? So they are both positive, so I will write 200 plus 150 cos 60 degrees. Now this 150 cos 60 degree is towards left, and this 100 cos 30 is also towards left, right? So they are both negative, so I will write minus 150 cos 60 degrees minus 100 cos 30 degrees, right? So how much is it now? 150 cos 60 and 150 cos 60, they will cancel out each other, right? So I will just erase them. So we are only left with this minus 100 cos 30 degrees, right? Let me use a calculator to find how much is it. Alright, it is approximately 113.4 pounds. 113.4 pounds. Okay. Now let's find the summation of forces in the y direction. Now let us assume the upward forces they are positive and the downward forces they are negative. Now 100 sine 30 degree, it is upward, so it is positive. So I will write 100 sine 30 degrees. Now this 150 sine 60 and 150 sine 60, they are both downwards, right? So they are both negative. So I'll write minus 150 sine 60 minus 150 sine 60, right? Now 150 sine 60 plus 150 sine 60, they are 2 times 150 sine 60, right? So I will erase this. It is minus 2 times 150 sine 60, right? Now 2 multiplied by 150 is 300, so it is 300 sine 60 degrees, right? So let me use a calculator to find how much is it. It is negative 209.8. Negative 209.8 pounds, right? So what does it mean negative? Now as you know, the downward forces are negative, right? So if I draw axis like this, what does it mean? Now summation of f of y is negative 209. Now the forces in y direction are negative when they are downwards, right? It was my assumption. So summation of f of y is downward like this, right? It is 209.8. Now summation of f of x is positive 113.4, and in the x direction towards right is positive, right? So summation of f of x is in this direction, right? Summation of f of x is 113.4, right? Now according to the parallelogram law, the resultant of these two forces, right, will be somewhere between them. Let us say this is the resultant, and the magnitude of resultant is whole under root of summation of f of x square plus summation of f of y square, right? Now summation of f of x square is 113.4, 13.4. Let me change the color. And summation of f of y is 209.8, 209.8 square, right? So let me use a calculator. Okay, I get the resultant approximately to be 238.5 pounds. Okay, so we found the resultant of this concurrent force system, right, using method of projections. So which one is the correct option? 238.5 is this. Therefore option B is the correct option. So this is how we find the resultant of concurrent force system. Okay, if you have any doubts, please comment, and see you in the next class. Thank you.